Welcome to the Daily Space Weather. Welcome to the Smash News Network, least busted name in news. Congratulations on realizing our channel exists. The closest star to Earth is this one right here, known as the Sun. A badly understood object when it comes to astronomy and cosmology. We just saw an M-class solar flare while I did show prep today. It came from sunspot 2887, I believe it's called. This active region down here. There does appear to be a coronal mass ejection associated with that. A bunch of fusion occurred. It even interacted with this other trailing sunspot, it looks like. Here's some more imagery from the Solar Dynamics Observatory. Just spectacular in the past few days. Here's your colorized magnetogram. Sunspot, whatever this number is. I want to say 2891, but don't quote me on it. It looks like it's degraded a little bit. These umbrae are very close together. They look like they're canceling each other out, in my opinion. Most of the activity continues in the southern hemisphere. The most interesting spot is this one here, 2887. Here's 94 angstroms, and you'll see right at the end of the video here, you'll see a little bit of a outburst from sunspot 2887. That was that M-class flare and accompanying coronal mass ejection. Here's a close-up of this new rising region. Yowzers. And here's the southern hemisphere, again, where most of the activity is going on. Just spectacular stuff happening as the sun ramps up toward solar maximum. So here's another imagery set of data here. This is the GO-16 SUVI. You see right at the end that M-class flare, that sudden brightening of that sunspot. The southern portion of that sunspot, right about there is where that flare came from. Very clear on the GO-16 SUVI. If you want to view the sun all day, it'll auto-refresh. The radial flux is all the way up at 111 now. 111 solar flux units is the 10.7 centimeter radial flux, the most proportional data set to sunspot number. There's the one-year chart of that, and you can see this recent sudden uptick with all of those major and complex, magnetically speaking, sunspot groups. The red line's the sunspot number, the black line's the radial flux. That's from solon.info. Next, we're on the Space Weather Enthusiast dashboard here. No solar storms. There is a geomagnetic unrest period forecasted for October 30th. And by the way, I think there's a coronal hole wind stream striking as we forecasted. Solar wind speed quite low. We'll get to it in a minute. First, global seismicity. We've got a bit of a drought in 7+ magnitude earthquakes here. That's last year's seismic activity in a convenient bar graph, and you can see about the frequency here of 7 magnitude earthquakes. There was a major drought at the end of last year. Here's the year to date, 2021. You can see there was a big uptick here following a drought. So when you see an earthquake drought, folks, if you're in an earthquake-prone zone, please have a plan if things should start to get hinky. In other words, if building facades are going to collapse and you're going to evacuate your building, have an idea of what buildings might collapse before evacuating yours. If you can't afford a bug-out bag, realizing there's a drought is some preparation, isn't it? Let's check out the USGS list. No major quakes over the past 24. We'll just scroll up the list here. Nothing too exciting going on, although some earthquakes happening there in Texas. I'm just going to scroll up the list here. If we miss anything that you'd like us to cover, let us know. There was a deep quake in Indonesia. 333 kilometers is the estimated depth for that 4.7 magnitude earthquake. Timor-Leste saw one of the largest quakes of the past 24. I think that might have been the largest. Only a 5.1 magnitude, but over 130 kilometers estimated depth on that. Tonga also saw a 5.0. Check it out. It's Cumbre Viejas. The sounds of the La Palma Volcano. You could go watch the webcam yourself at kaimedia.es/es/play. Yes, some spectacular imagery here, and you can see some incandescent lava. It's light in the Canary Islands. The sounds and sights of the La Palma volcano. Some dark-colored smoke coming out there, some outgassing happening, possibly some phreatic activity. Some of that could be steam, some of that could be sulfur dioxide. Certainly a bunch of it is volcanic ash. Let's move on to see what else is erupting around planet Earth. So there was some explosive activity. We just covered it live. That's producing a 10,000-foot plume of volcanic ash. Subanose-jima, 8,000-foot plume of volcanic ash over the Ryukyu Islands from Subanose-jima. Mount Ibu, now back on the list, exploding, 6,000-foot ash plume from Ibu. Popocatépetl dispersed its ash and fertilized the country of Mexico. Fuego has dispersed its ash as well. That one's located in Guatemala. Nevado del Ruiz has dispersed its ash, fertilizing Colombia. Yes, even the sulfur is actually good for plant growth, folks. Were you aware of this? Yeah, carbonyl sulfide. It's a very important global cooling gas that causes clouds to nucleate and plants to grow better. Yeah, they like their sulfur. Sangay also exploding. That's a 20,000-foot ash plume over Ecuador. Revenador from that same country also exploding, 16,000-foot ash plume from Revenador. Sabancaya exploding, 24,000-foot ash plume. Nevado State Chilean exploding. Possible emissions of volcanic ash up to 12,000 feet. Please don't fly your John Denver-style aircraft over the caldera, and please don't attempt to pole vault it. Please do visit our links. You'll find them below the video. Support the channel financially, as YouTube pays us just a side of nothing. In fact, it even demonetized yesterday's live stream. We'll share it once again once it gets remonetized, because we were candy apple and we didn't say anything even remotely controversial during the stream. So anyway, smashomash.com. The Smash team. If you click smAsho merch, you'll find this. We've put it in order of best selling. And we've clicked the Explore Designs link there. So check out the merch shop. Yeah, we've put the face of evil, Dr. Fauci, on a product. Today's featured product is Mensa, Make Earth Not Suck Again. Part of the reason we have a YouTube channel is to make Earth not suck again, because we've noticed a bunch of crap, nonsense, fraud, propaganda, grifters, people getting paid millions of dollars per year to outright lie to their viewers and attempt to gaslight people in the comments section. Cheers to all of you YouTube hack frauds. Congratulations on cashing in on a system and cashing in your own credibility. We're out here making Earth not suck again, so support that. Tell your friends and foes about it by picking up some merch, maybe some leggings, or perhaps a dress with our Mensa design. Make Earth not suck again. It's up to you, not bureaucracies that can't even get out of their own pathetic joke of a way. Let's shift gears and look at magnetic data for a bit. There's the GOES magnetometers. That's the GOES 16 and GOES 17, by the way. Fairly smooth curves here on their recent measurements, just a normal range. Here's the polarity of the heliospheric current sheet. It's part of the Gong 2 data. We look at it daily on the Daily Space Weather because this is one of the most important factors in, frankly, observing and forecasting space weather, solar activity, things like that. Just that kind of stuff. No big deal, just understanding the closest star and how it interacts with the Earth and things like that. I don't know why average astronomers don't seem to know very much about this. But in any case, there is the massive plasma laboratory going on in the solar system right now. Don't be confused by this. It's not to scale. And you can see Earth about to make a transition into a North Pole current sheet once again. And I would tend to agree with that likelihood. Next, the line of sight view. It also shows the solar magnetogram. Yeah, I would expect a North Pole current sheet to be coming, and I would expect this northern sunspot to degrade. Yeah, there's a sunspot evolution forecast for you. That sunspot in the northeast, it's going to degrade. Watch if you don't believe me. I figured out how to forecast solar activity and also the mechanism underlying the solar polar field reversals and hence the solar sunspot cycles. Yeah, I'll have to write a paper about it. I guess it's kind of important. I'm paid just this side of nothing to do it. Please support the channel financially. Share with your friends and foes, lest we stop making the videos entirely or they become private, not publicly visible, not free for all to view. Anyway, here's the line of sight coronal hole plot. We've got some North Pole oriented coronal holes around that sunspot. It's going to degrade. Just watch. And let's take a look at the coronal hole scenario from the 193 angstroms SDO imagery. And the only real coronal holes we see here are in the northern hemisphere there, northwest of that sunspot group that just rose in the northeast. So coronal mass ejection warning continues. We just saw one happen as we did show prep. Solar flare warning continues. The likelihood of major flares is certainly still there, especially from sunspot 2887. So beta-class sunspots for you new viewers out there, beta-class sunspots much more likely to produce major solar flares because of their magnetic complexity. Here's the solar flaring over the past 3 days, and there's that M-class flare that occurred while we did show prep today at peak flux was around 7:40 universal time today on October 28th. It caused a bit of radio blackout over the central Indian Ocean mainly. So mostly a harmless radio blackout there. And this deabsorption region, this is what we're talking about when we say the ionosphere starts absorbing your radio signals instead of refracting them back to your, wherever you're trying to send your radio signal. That's called a HF radio blackout. No spikes in the proton flux yet. Sometimes when coronal mass ejections happen, it takes as little as 30 minutes for protons to strike the Earth. None striking the Earth yet from that M-class flare. It could happen. It's quite earthly facing. We're not even going to attempt to look at the ejecta yet, as it's too early to get telemetry on it. Probably make another video later today about it if there's anything interesting to cover. So it looks like we see the onset of a coronal hole wind stream happening here. It looks pretty weak and diffuse, but we did see this small uptick here in the solar wind density. So we're at about 7 protons per cubic centimeter for the solar wind density. Solar wind speed only 300 kilometers per second. Very slow, and it's not a significant coronal hole wind stream. We'll see if that goes any higher. We expect the density to drop back down and the speed to come up, the signature of a coronal hole high-speed stream. KP index is only at 1. That's a measurement of global geomagnetism for new viewers out there. And next, the magnetohydrodynamic pressure modeled by the Space Weather Modeling Framework over the past 4 hours. Plasma spheres are looking large. Those would be these empty-looking spots right here. Those are the areas where a bunch of complex molecules get built because of plasma getting trapped in that area. When plasma comes in, folks, just a little demo here. When plasma shows up at the magnetosphere, it's got to make a decision. Is it going to bounce off and get reintegrated into the solar wind regime? Is it going to spiral into field-aligned currents and do things like create the aurora borealis and aurora australis? Or will it spill off somewhere in between there and get stuck in the plasmaspheres? That's all the stuff that's going on above your head. If you're frightened of CERN, there's a lot more interesting stuff happening in nature constantly. CERN isn't the slightest bit scary. If you're frightened of CERN, don't leave us a comment. Or maybe do. We don't censor anybody on the channel. I'm a censorship purist, but I might berate you, especially if you sound like an idiot with no physics explanation of your insane claims. Here's 4 hours of data of ground magnetic perturbations. Geospace delta B changes to Earth's B field on the ground level. Not a lot of changes happening. What with the relatively weak, very slow solar wind speed. Here's what's going on in the solar system. And if somebody's telling you that when the Earth swings past Jupiter the next time that something scary and spooky is going to happen, what happened last year? Do you remember last year when Earth swung by Jupiter and Saturn where they were aligned, and then later they were aligned in our sky, and people thought it was very scary and spooky because reasons, and it was going to cause some kind of catastrophe, and nothing at all happened? You remember that? Guess what's going to happen next time? You know how far away these things are from each other? This is not to scale, folks. The distance between Jupiter and Saturn is like 1.6 times the distance between the asteroid. Now, I'm not going to go there. Everything's not connected. Everything's not electric. There are no mysterious Birkeland currents connecting Jupiter and the Earth. That's complete and total nonsense. Take a physics class if you believe this crap on YouTube. Let's advance this 1 week. There's where things will be in a week. It looks like 1 day. It looks like we're 8 days from the new moon. Beware of all the reverse vampires out there. Next, a star chart. Look at the way the ecliptic and the galactic plane are crossing right near the zenith of my sky, does that mean something scary and spooky is going to happen? Well, absolutely not. Turns out if you keep looking at stuff in depth, you might find out things you didn't know otherwise. Please don't believe nonsense propagated on the internet and get people paid millions of dollars to lie to you and then attempt to gaslight people who refute their nonsense. Let's do a cosmology segment. It'll be nonsense-free, as all of our videos are. That is, of course, except for when we put up nonsense intentionally to amuse our viewers. So we're going to look at some cosmic ray monitors here, and we saw some wild swings in cosmic rays over the past about 2 weeks, both at most of the reliable cosmic ray monitors. And when I say reliable cosmic ray monitors, I mean ones that don't have a bunch of crap data in it because they're not at an appropriate location to measure very sensitive cosmic ray flux. Anyway, so the last 30 days at Apatity featured an uptick in cosmic rays, along with these wild swings over the past, again, 2 weeks. Barentsburg showing about the same chart here, a little bit flatter, but an uptick at Barentsburg. Let's go farther south to Athens, Greece. And by the way, today's cosmology segment's integrated into the daily space weather video. Make sure you check our cosmology segments on our playlist. There's over 200 videos in our cosmology segments playlist. Go watch them. They are spectacular. And the cosmic ray profile at Athens has been flat over the past 30 days. There's a 30-day graph at the Athens neutron monitor. How about Mexico City? Going even farther south, there's Mexico City, which is flat over the past 30 days as well. But you can see these large variations over the past 2 weeks, an indication that this data is not crap. Last but not least, we'll go to Apatity. Not Apatity, we'll go to Oulu and 2 Antarctican monitors. So once again, you see this data right here, an indication that it really is energy from space in the form of incoming protons and so on, the particle showers associated with them when they strike the atmosphere. An uptick at Oulu over the past 30 days. DOMB Antarctica, an uptick over the past 30 days. DOMC Antarctica, an uptick over the past 30 days, despite an increase in solar activity. If you want to read more about this, head to our forum at smAsho.com/forum. There is a subject there completely devoted to the grand solar minimum. So if you click on forum, you'll find our subset of lots of different forums. One of them is a forum on the sun. So we've got forums on cosmology, on Earth and geophysics. There's a free-for-all forum, general science, our content, the sun, and new users. It's completely free, so check it out if you haven't. smAsho.com/forum. And here is one of the charts that you can view on the Grand Solar Minimum thread on the Sun Forum. This is showing you cosmic ray flux along with solar activity. And I'm not going to say anything more about this graph other than if you don't understand this graph, you don't understand cosmic ray flux, grand solar minima, what the term even means. And if you're covering up this graph, you're probably a grifter, and you're probably making 6 figures on YouTube because YouTube, for some reason, decides to promote propaganda, fraud, and disinformation instead of actual science. Check it out. It's a ghost right there. You see that? That's a ghost. And that is a fairly close star. I think it's only located at about 400 light years. It's the astronomy picture of the day at apod.nasa.gov, apod.nasa.gov, which is showing Mirach's ghost, which is this galaxy known as NGC New General Catalog 404. That is Beta Andromedae, located in the constellation of Andromeda, obviously, with a galaxy in the background. If you want to check it out yourself, again, apod.nasa.gov. Today's random number is 55. Is it really random? Is it live or is it Memorex? Today's random number is 55. It is RGB J0136 plus 391, which is a BL Lacertae object, a type of active galactic nucleus. There are the hard X-rays from it. Let's go see if we can find it visually. So I've clicked on Simbad, and from Simbad I've clicked on CDS portal, which brings me to this page. And I've scrolled to the bottom to show you what BL Lacertae objects are like. They are active galactic nuclei that are bright in some frequencies but not others. So it's the opposite of a broad spectrum blazar like what we showed yesterday. Yesterday's daily space weather video featured a cosmology segment as well. We saw a full spectrum blazar, a different type of active galactic nucleus. This is a BL Lacertae object which has brighter photons in certain portions of the frequency range than others. So let's take a look at this in some other frequencies here. This one here that's the DSS, which is an optical survey. And I'm just going to see if we can find this in some other frequencies here. Does it show up on the Swiftbat X-ray? Well, not really. Does it show up in ultraviolet? Indeed it does. A great ultraviolet signature there from the Galix. You can see how bright it is compared to the relatively empty space around it in ultraviolet frequency. Let's see if it shows up on Pan-STARRS, which is a great optical survey. There's that BL Lacertae active galactic nucleus. And the brightness of the galactic core is obscuring large aspects of that galaxy. How about the thermal emissions? There it is on the 2MASS. The BL Lacertae object, the quote random end quote object of the day, RGBJ0136 plus 391, a catchy name, entry number 55 at the Neil Gehrels Swiftbat X-ray Observatory transients page. That's today's cosmology segment. Again, check our playlists for all kinds of other videos. Charging hazards are non-existent around planet Earth right now, but we've got some chaos in the electron flux. We'll get to it in a minute. Here's the 1-year chart of the relativistic electrons. Here's a 3-day chart of the relativistic electrons. These are the greater than or equal to 2 mega electron volt electron flux by the GOES 16 and GOES 17. Here's the forecast. Expecting an uptick, I would say this is going to be down here, not up here, because it looks like a weak coronal hole wind stream's arriving. Next, we're going to show you the total electron content forecast. First, a diagram of Earth's Van Allen belts and distances to things in miles. Here's a total electron content forecast, and we're seeing some quite chaotic electron belts forecasted here, especially some major errors over both the southern Indian Ocean, North America, and some surprisingly significant errors over the Central Pacific. You can see those red blobs there. Those are associated with really large GPS errors. And it doesn't need to be particularly yellow or orange to have your GPS off by thousands of miles and calculating your bike ride as an average speed of 10,000 miles per hour average speed. So some chaos happening in Earth's magnetosphere, at least according to that total electron content forecast. Next, a diagram of the atmosphere showing you where the F layer is. It's the F layer of the ionosphere, in many ways the bridge between Earth and space. Here's an animation of that. There are lots of chemical reactions going on up there. It's causing a lot of vibration. And there it is in megahertz. We're going to look at the anomaly map next. Here's the anomaly in megahertz. That is departure from the 30-day median in megahertz. And you can see some low-frequency anomalies here over places like the Middle East, Northern Africa, and then moving down toward the South Atlantic anomaly, which, by the way, is located right about here now over the South American continent. Mainly high-frequency anomalies in the southern hemisphere, some major anomalies there over the Central Pacific. So we're seeing some signals there, both in the electron flux and the ionosphere maps. There's the latest image. That's 8:30 Universal Time, ionogram, and the anomalygram. Hey everybody, thanks for tuning in to another meteorology segment. Congratulations on realizing our channel exists. Let's get to some whether or not your weather is covered will be up to us. Here are the surface winds of the eastern world. Okay, they're the eastern winds. Okay, here are the jet streams of the eastern world. Oh my God. Here are the jet streams of the western world. The jet streams are the most significant global weather pattern you could look at. If you had to look at just one thing to forecast global weather, the jet streams would be the thing. Because right here, I would bet the farm there are clear skies over that area. An indication of high pressure, most likely. Anyway, look at the extreme meridional jet stream flow. It looks like Charlie Brown's shirt. Perfect example of extreme meridional jet stream flow there over North America, the Atlantic Ocean. And a powerful low here, stretching all the way to the jet stream in the south central. That's actually the south portion of the North Atlantic. Anyway, let's move on to talk about our forum and our mission. Are you familiar with our mission? Well, I'm going to tell you all about it. You can go find it yourself at smashamash.com/forum/mission. It's to assist, study, and report on the ongoing formation of a unified theory of physics, to raise the awareness of the general public of the relationship between space weather and Earth effects, to connect and consult with media organizations to multiply our reach, to demonstrate cutting-edge proof-of-concept solutions to problems, to publish scientific papers in a multidisciplinary manner, including but not limited to sciences like spectroscopy, chemistry, physics, astrophysics, health, wellness, longevity, cosmology, biology, magnetohydrodynamics, geology, etc., to assist mankind by advancing the study of predictive phenomenon in order to optimize value and reduce risk and liability and save lives and resources and adapt no matter what the adversity is. And last but not least, to not be ossified in our beliefs and to treat those who are with love, respect, and inclusion to the scientific discussion. smashamash.com/forum is part of the mission. Also, the Smash Team, smashamash.com/smash team. We've replaced Patreon with something superior. More on that in a moment. Next, your weather.gov map. Yeah, weather.gov. If your county's lit up, just click on it. No further comment there. Some strong lightning in the Gulf of Mexico, as noted by the GOES Lightning Mapper. Here's a real-time lightning map from lightningmaps.org. Is there terrestrial lightning in the U.S.? Well, certainly not. Maybe. Oh, I think we've got some in Florida. Hey, Gainesville. There could be thunder rolling in. To your west, Gainesville, Florida, showing up on the map. Not sure the way that system's going to be moving, but you'll know by the end of this video. Here's the precipitation forecast. This is the GFS forecast for average precipitation rate. It's over the next 72 hours from Tropical Tidbits. And this low is going to weaken and then start to finally allow this moisture to break up. So you can see the low is getting a little indecisive there in the next 72 hours as it weakens. Next, a pressure map. Here we are on windy.com. Let's actually zoom out to the global view. There you go. There's your global pressure scenario. Powerful low there at the south of Iceland. We'll advance this. This is the European forecast for pressure at 1 p.m. Eastern Daylight Time tomorrow on October 29th. This video was originally streamed live to Twitch. Thanks to our new followers over there, twitch.tv/smashamash. We'll be doing more and more content on Twitch. Don't believe me? Just watch. Gaming videos, all kinds of stuff. If you're only viewing on BitChute, make sure you go subscribe on Twitch and especially YouTube. If you're only viewing on Twitch or BitChute, you're missing like 90% of the content. We've been putting up our meteorology segments on to BitChute. Meteorology segments like this one, thanks to our subscribers over there, approaching 600. If you're viewing the videos on YouTube, press like, subscribe, tell your friends and foes about the content. I don't think the algorithms are doing it. We did a 2-hour live stream yesterday. It got demonetized. You probably can't even find it. Good luck. We didn't even put it up on the Smash Team, smashamash.com/smash team, but we will. smashamash.com/smash team, the real replacement for Patreon. When you log in, here's the page you'll see. And the key is click on posts. Yeah, posts. It's way better than Patreon. If you don't believe me, I don't know. Go sign up for a bronze membership. It's completely free. There's also a paid $2.99 per month silver and a $9.99 per month gold membership and a paid up annual gold membership as well that entitles you to some complimentary merch. And that's all you're going to get to see from the Smash team, because you've got to go to our own website. You can also find links there to the smAsho merch page. We've ordered these by best selling. Today's featured product is the Mensa product, because part of the reason we make these videos is to make Earth not suck again. So please contribute to that, contribute to our existence, increase the probability these videos will continue to exist, remain publicly visible, and free for all to view by picking up some merch, supporting the channel financially via becoming a Smash team member, picking up merch, making one-time donations. All kinds of links are below this video. Next, we're looking at the water vapor profile over the Pacific Ocean, Earth's largest heat sink. Yeah, Earth's largest heat sink, the massive heat latency of all that water in the Pacific Ocean. Look at all the air above the Pacific Ocean. That's got a very low heat latency compared to all the water in the Pacific Ocean, which has a lot of heat latency. Let's just say it takes a lot of calories to heat up the Pacific Ocean. Continuing on to our radar.weather.gov, radar.weather.gov if you want to see this Doppler radar map yourself. As precipitation continues to stagnate in the south of Alaska. Yowzers, we're in the Pacific Ocean. All right. And there is the lower 48 scenario on radar. Heavy storms here moving into Georgia, about to hit South Carolina. Here's what's going on in the cloud layer. I apologize for that. And since we're streaming live, we had to refresh those. All right, so there's what's going on in the cloud layer. Here's what's going on in the water vapor. And the jet stream kind of taking its good old time moving that low out, which is why convective forces are going to be in charge over the eastern portion of the country. So once again, here's your recap. There is your Doppler radar scenario from radar.weather.gov. Additional heavy rains and flood watches showing up there in the Pacific Northwest. Here's the cloud layer. The 3.9 nanometer radiation map shows you clouds and fog when it's too dark to see them with the visible satellite. It's why we use it. It's the shortwave radiation map from the Interactive Weather Satellite Suite. And last but not least, here is the water vapor map, the most definitive one you'll see. If you're wondering what's going on with your weather next, click the map like this, set up an animation for wherever you're located, and that will give you great insight, especially if you realize that this air right here is of higher pressure and more massive than this moist air here, which is at a lower pressure and less massive. Hopefully that helps. Hopefully you're able to forecast your own weather. Thanks for tuning in. I've been your host, Dan, a.k.a. smAsho, signing off from the Smash News Network, least busted. Name it news. Here's your ground-based solar observatory. Here's the latest intensitygram, I think. Sunspots all look like they're degrading at the moment. And we've timed out the website. Let's switch to the latest solar imagery. All right, so here we go. Here's 171 angstroms. Sunspot 2891. I think it's degrading. The fields are too close to each other. Here's the southern hemisphere, which is where most of the activity is. And we'll zoom out for a full disk view to close out the video. Thanks for tuning in, folks. Congratulations on realizing the channel exists. Press like, subscribe, tell your friends and foes about us. And may that solar wind be at your back.